In this demonstration, I'll show you how to solve equations that contain radicals. This is part 2 in the series. The steps to doing this correctly are outlined below, and we'll refer back to this later on in the question. The first thing that I like to do whenever I'm solving an equation that contains a fraction, notice this part contains a fraction, is I like to convert the equation so that it doesn't contain that fraction. And the way you do that is by finding the lowest common denominator. The denominator for this term is 1. The denominator for this term is the square root of x minus 3, and the denominator here is also 1. What I can do is multiply each of these three terms by the square root of x minus 3, and that's what I'll do. By doing that, this term ends up becoming a normal non-fraction term. So as I said, I'll multiply the whole thing by the square root of x minus 3. Doing that, the square root of x minus 3 times the square root of x minus 3 gives us simply x minus 3. Remember, multiplying two square roots, let's pretend that we had the square root of x times the square root of x, gives you simply the radicand x. So the same logic applies. Multiplying this by that gives you the inside. This multiplied to this fraction gives you the square root of x minus 3 over the square root of x minus 3, and that equals 1. So plus 1 is equal to the square root of x times the square root of x minus 3. The next step is to simplify the right side. And at the same time, I can combine negative 3 plus 1. That gives us x minus 2 is equal to. Now, you're multiplying two radicals with the same index. They're both square roots, so you can multiply simply the radicands. So the square root of x times x minus 3. Now that I've isolated the radical term on one side of the equal sign, as shown, I want to raise both sides to whatever power will eliminate the radical. So this has an index of 2. I'm going to raise both sides to the power of 2. And what happens when I do that is this radical symbol goes away. You simply end up with x bracket x minus 3, and on this side you now have a binomial times a binomial, where you have to expand using the distributive law. Let's do that on the side. X times x is x squared. X times negative 2 is negative 2x, negative 2x plus 4. Combining these, I end up with x squared minus 4x plus 4. Let's take this and place it right here where it belongs. And let me do the same thing with the right side. I'm going to distribute this x to the two terms. And that gives me x squared minus 3x. So let's replace that with this. Now I'm going to collect like terms. This and this term are alike. This term and this term are alike. And this term is on its own. So I'm going to bring all of my terms to one side. X squared minus x squared, that becomes 0. Negative 4x plus 3x, notice that this was negative, it's now positive, plus 4 is equal to 0. Combining these two terms, I end up with negative x plus 4 is equal to 0. One more step. Bring this 4 over, becomes negative 4. And you have a negative on both sides, they cancel out, and you're simply left with x is equal to 4. And you can check your answer by plugging it back in to your equation. Let's do that. Using our calculator, the left side should equal to the square root of 4 minus 3 plus 1 over the square root of 4 minus 3. This gives us 2. And if I put a 4 into here, the square root of 4 should also equal 2, and it does, and that is the correct answer. So there you have it. That is how to solve equations that contain radicals.